lucrative offers from top technology companies, cushy life in European cities, and offer multiple grant and non-dilutive grant offers to start their company in Europe. These are some of the things Dr. Sarkar and Dr. Sinha sacrificed to build a deep tech company from India. I want to invite my friend, Dr. Sarkar, Prashanta. He's building one of the first commercialized membraneless green hydrogen electrolysers from India. Let's hear about the story of Newtrace.
Good afternoon. Can you hear me? Right. Thank you, Vishnu. I had almost forgotten that I did a PhD. He reminded me today. Right. So guys, my name is Prashant. I'm the co-founder and CEO of Newtrace. We are a Bangalore-based climate tech company working on enabling affordable green hydrogen for decarbonization. Our journey is very interesting, and that's why I want to run you through a bit of that. So Rochan and I, we started the company back in 2021. Prior to that, we both spent most part of our career, close to a decade each, in Europe. So I'm primarily an aerospace engineer. I went out after my undergrad in India, moved to UK, and then I worked for Leonardo Helicopters, building rotor blades for modern helicopters. Post that, I went on to do a PhD in Grenoble in France, working on cavitation bubbles, which affects the fluid system, but we are also working with UK Cancer Institute on finding novel ways of targeted drug delivery. Post that, I was moving to Denmark, and then I came to India. I traveled across the world, but never across India. So came for a backpacking trip of 6 months from Kerala all the way to Nepal, went to Annapurna base camp. So while I was doing that, few things were very evident to me. First was, so I come from a very small city in India, in the eastern part called Agartala. The cities that we grew up in, the weathers were used to be 28, 30 degrees, have moved to around 48 degrees. My father has somehow put up 2 air condition. Slowly, he'll probably put up air condition in all the houses, right? And energy was available to a certain population of the country. The other population in the remote areas were still struggling for 24/7 energy. And I'm a firm believer that after the Roti Kapra Makan, we have to focus on energy and healthcare, right? And equitable and fair access to energy is going to be a very strong precursor for our society to develop. My co-founder, Rochan, is a material scientist. He studied nanoscience and nanomaterials in Belgium, worked in IMAC, which is the leading solid-state battery research institute with Shell and Panasonic. He went to differ in Netherlands to do his PhD on photoelectrocatalyst materials, which are materials that can directly split water into oxygen and hydrogen. He was going to join ASML, making those beautiful, fancy machines there, but was back in India during COVID, and we met up. When we met, few things were very clear to us. We wanted to work on building something that fights climate change, because we are very firm believer that the time to fight climate change is not a decade later, but now, right? It cannot be a magic brush that comes and sweeps and solves all the problem. It has to be incremental steps, and that has to start from now and then. And we wanted to build something that has an impact on people's life, maybe not a consumer-facing app, but an indirect energy security for the masses. So that was the initial focus of how we started to do, and that is the North Star that still defines the company, while we try to create value for our partners, investors, employees, and everyone else. We are truly driven by solving for the harder problems for climate change. So hydrogen, right? So most of the world has heard about hydrogen from Elon Musk. And the context has been that batteries are efficient than hydrogen, and that is true, right? But what Elon Musk is talking about is from a personal mobility perspective. What we kind of forget is the world produces 100 million tons of hydrogen in every year, and it is increasing to around 240 million tons of hydrogen. And this whole production of hydrogen in the world from fossil fuel, primarily natural gas in the rest of the world and coal in China, is responsible for 1 billion tons of CO2. Back when we started, it was also very interesting that climate change and electrification had become synonymous, right? And if you look around the world, in economies like India and US, yes, mobility does give out 20 to 40% of the CO2 emission, but overall in the scheme of things, cumulatively it is around 16 to 18%, right? In that also you have segregation of personal mobility, you have segregation of long-haul mobility like rails, trains, ships, planes, trucks, buses, right? And somehow we were focused, we had made the whole climate change a very consumer-centric problem, that go buy electric car, go buy the electric scooter, those are necessary, right? But if we are looking at a 1 million vehicle which is offsetting 2 tons of CO2 every year, we are looking at 2 million tons of CO2 in 1 year. That is 25% of an emission coming out of one refinery, right? So somehow we were not looking at solving the harder problems. It's not like the large industries were not interested in solving those problems. It was just that it was not attractive enough in terms of sectors to solve for them, right? People were more concentrated about making consumer apps that were putting them in front of the Forbes and stuff like that. They were not going out to solve the harder problem because you have to solve for products which operate in multi-million-dollar industries, products which are very hard to build, and solve for a massive, massive problem, right? Because most of the emissions were coming from the chemical industry, the steel, cement, electric generation, fertilizer, methanol. So where is hydrogen used is a very fundamental question apart from the, the mobility part of it. I am a firm believer that energy will play out to be an eclectic in the future, where we'll have different forms of energy running out different forms of lifestyles. So hydrogen finds its application in refinery where they use it to process the crude oil that we are going to use. And as I said, we will have a very slow, gradual transition from fossil fuel to any form of other mobility. The other key form is making ammonia, which is fertilizer, right? And these are the applications where you need to use hydrogen as a molecule. You cannot use an other alternative source of energy because you're not looking at an energy, you're looking at a molecule, right? The steel and cement sector, they have to burn large furnaces, and this is where they're also looking at. When you burn hydrogen, you don't emit any CO2. You emit a little bit of NOx. You would have definitely seen that Ashok Leyland, Reliance Industries, they are starting to demonstrate buses and trucks which are powered by hydrogen, either converting the hydrogen into electricity or converting or burning the hydrogen in an internal combustion unit. So there is a versatile application of hydrogen that can go with other forms of energy in terms of decarbonizing our sectors. Now, as I said, most of the hydrogen is coming from natural gas and coal. The alternative is green hydrogen, which essentially is splitting water into its constituent of oxygen and hydrogen using a renewable form of electricity. What it does is basically it provides you the molecule with which you can make fertilizer, make other chemical compounds like methanol, also produce electricity. It solves for the intermittency of the solar energy. The other factor that people are looking at is basically how do you provide energy to areas where you don't have enough renewable electricity. So business models like making ammonia in India, in Middle East, and shipping it to Europe is something that a large part of our industries are also exploring. In terms of green hydrogen, the splitting of water to make these molecules of oxygen and hydrogen, it is primarily done through a process called electrolysers, which we have all, I think, studied. But the challenge has been that this whole electrolyzer industry has been primarily based in Europe. The supply chains are very restrictive. There are 2 companies in the world that makes 99% of a very critical component called membrane for all the electrolyzers. The order books are full, nobody's getting a supply. As a result, the whole industry is struggling to get enough electrolyzers to decarbonize. And you have to understand that for the scale that we are talking about, it doesn't solve for just installing 1 electrolyzer or 2 electrolyzers. You're talking of thousands of electrolyzers to meet those targets, right? There is a lot of usage of platinum and iridium, rare earth metals, which are not enough. Right now, to make 1 or 2 products, you're getting it from South Africa and other countries. But the supply of those rare earth and the processing in China is, again, very, very limited. So as a result, the industry was facing a lot of challenges in terms of scaling it up. And this is what we went on to solve for. So what we make is, we make non-PGM, which is basically no rare earth metal, no platinum group metal, and membraneless electrolyzer. So membrane is the key component that only 2 companies in the world could make. And we design it all indigenously in Bangalore. We manufacture it in our facility in Bangalore, and we make it for sectors like refinery, long-haul mobility, steel, cement, fertilizer, to enable them to decarbonize their processes. I'll not go into much in the technology, but the important bit is that the fossil fuel hydrogen was around 1.2 to 1.5 to $2 per kg, and the green hydrogen was around $6 to $11 per kg, and it would never make sense for any company to decarbonize using such expensive fuel, right? What we are trying to do is we are trying to reduce this delta, bring down the cost of green hydrogen from water and renewable electricity at par with fossil fuel hydrogen, right? And enable them to really start the transition process, which will take a decade in our opinion. In this, we work across multiple different parts of the product, starting from novel electrocatalyst that gives us the juice for providing energy to the water to split it up, to making innovative stack, to designing plants for refineries. We also make software on top of the hardware. We also make predictive maintenance tools right now, which are getting tested for pilot deployment. And one of the other things that we focus on is building up critical supply chain across this country. We have no record of mass-scale manufacturing of electrolyzers in this country, which means that we have to go on a discovery process day in, day out to find suppliers. This is a problem that we alone as a company cannot solve. We have to build an ecosystem that has to come together, build different parts of the product, and build out the entire ecosystem for green hydrogen production here. I'll talk about a bit on our journey. So Rochan and I, we did the initial part of design in our apartments in Indiranagar. And then we had to make the first prototype. And we were not from the scenes here. We were just a few months old in India. So we sent out emails to leading research labs. All we needed was a table to make something and ask an investor to come and see it, because we thought that the investor would not believe if we asked them to come to our apartments. So we're also not very fond of paperwork. And I think Professor Satya Chakravarti, if he's here, he was kind enough to respond to our request. No paperwork. He gave us space to our lab and gave us some initial support in order to build the first prototype. So very, very thankful to him for the kind support in the initial days. We built up the prototype in 2 months, met Vishesh, and since then our journey started really. We went on to raise our pre-seed round from Speciale and also Micelio. We started demonstrating really ultra-pure hydrogen from the small setups that we are building. Since then, we have scaled our product 1000x in less than 2 years. Just last year, everything looks like last year to me. Just early this year, we raised a $5.6 million from Sequoia Capital, which is now Peak 15, Avishkar, and our existing investors as well. And we are currently working on our first deployment. Under 2 years, we are generating revenue. We are working with some of the leading oil and gas companies in this country. We are working with some of the leading manufacturing companies in order to come and work with us on how do we make thousands of these electrolyzers in this country and ship it to the world. So what you see on the left is what we built in IIT Madras on the tabletop. Since then, we have built larger and larger. Just for reference, there is a person standing there. So between this to this, there is a 10,000x in terms of size, scale, production that we have done. So that's the product that we are shipping out and currently working on our deployment. And all this under 2 years. Right. What we are trying to do here is, hydrogen is the first part of the puzzle that we are trying to solve. There is a lot of opportunity and a lot of problems that exist in the industrial sector in terms of making different specialty chemicals, relying on a lot of fossil fuel, finding alternative energy source. And what we want to do is basically, once you have scaled up hydrogen, we want to go and address those problems as well. There is a lot of different interesting problems that emits a lot of CO2, and we want to build technology for that. So essentially, we are a technology infrastructure company that is making hardware and software to address those problems one at a time. And the reason why we do the manufacturing is very interesting, because we are not just looking at making a solution and passing that solution as a license to somebody else to figure it out. What we want to do is basically take the product to scale where it is mass manufacturable, which means that we also have to go and invest on manufacturing, solve problems in manufacturing, because manufacturing at scale is a massive problem, and I would say $1 billion opportunity for us in this country. We have also been very lucky, I think, to have been working with Speciale. They have worked across with us since the pre-seed round in getting us to those, be it investors, customers, partners, vendors. They work with us as if they work in the company, day in, day out. They are our thinking partners. They are our partners for figuring out what's next. And we are really thankful to them for their support through the entire Speciale team. Right. So as a company, we believe the time for change is now in terms of the energy transition. And we are building for it. We are building in India, and we're building for the world.